Everyone at present knows the importance of data and information. However, the realization of the importance of data and information was from prehistoric times. Although the human brain has a great storage capacity, sometimes we forget about the data stored in our brain. Also, it is non-transferable. Therefore, humans started searching for tools and devices to store data and retrieve them in need. Today, this video is about the history and evolution of the data storage tools and devices. In the prehistoric times, our ancestors started storing data and information in carvings and paintings on the walls and on the rocks. Cave painting was famous between 40,000 BC to 3500 BC. Since most of our ancestors were nomadic, it was difficult for them to carry those data in the cave rocks with them. Therefore, they started writing on papyrus between 2000 BC to 1022 AD, and then on paper between 105 AD till the present. They were portable. However, materials used to get lost or get damaged over time. Information on the woods, stones, papyrus, paper was difficult to store, locate, and use. Therefore, humans started developing devices that would easily store data, easily access them, and store them for a longer period of time. In the modern era, data storage started in the form of punch cards developed by Herman Hollerith in 1800s. The first punch cards contained 45 columns and 12 lines. Later, 80 columns and 12 line punch cards were developed. These punch cards were made by punching holes at predetermined places, coding one character per column in each row. It had a limited capacity of 0.08 KB and could hold only about 80 characters. The significant drawbacks were limited storage and permanent storage of the data. In the 1930s, drum memory was introduced. Drum memory was made up of the large cylinder, which was stationary. The drum sped around at high speed while the head waiting for the relevant piece of data to come. Drum memory can store around 65 kilobytes of data. In the 1940s, cathode ray tube was introduced for data storage. This is the same technology used in old CRT television, which fires electrons to create patterns representing zeros and ones. In 1947, William Kilburn tube was introduced, which could save 0.128 KB of data and was the first form of RAM, that is, it had a random access to memory. In 1951, magnetic data storage appeared, which completely replaced punch cards and punch tapes. Magnetic tapes can save 231 KB of data and had a 1200 foot roll tape. Magnetic tape has more data storage capacity. The major disadvantage of magnetic tape was serial access, which means if you are listening to song 1 and if you want to go to song 4, you need to move the tape manually and it has a slow access to data. In 1956, IBM introduced 305 RAMAC, which could store data equivalent to 64,000 punch cards, approximately equal to 5 MB. It was a significant increase in the data storage. However, IBM RAMAC weighted over a ton and monthly leasing cost was $3,200, which is almost equal to $30,000 in 2021. In 1971, there was a revolution in the magnetic data storage by the introduction of the floppy disk. The most valuable feature of the floppy disk was it had random access to data and decreased size. Floppy disks were introduced in the various sizes from 8 inches to 3.5 inches with a standard capacity of 1.44 MB. In the present day, I believe 1.44 MB is not sufficient to store a good photo. In the 1980s, optical storage disks appeared and replaced magnetic disks. Data was stored in the optically readable medium using the light reflecting ability. These disks were written and read by laser beams. CDs have a storage of 650 MB, while DVDs have a storage of 4.7 GB. Currently, the most used optical discs are Blu-ray discs, which use blue laser beams and have a capacity up to 25 GB. The following picture of Bill Gates shows how much of paper is replaced by one CD. In 1998, Pendrives was invented by IBM to replace floppy drives in the ThinkPad line of product. These were in the size of 8 MB, 16 MB, 32 MB and 64 MB. At present, we hardly see pendrives, but they are still available in the sizes of 8GB, 16GB, 64GB and 128GB. The concept of cloud computing was brought in 1960s, which was especially designed for the universities and was not popular to the general people until 1990 because of the inferior internet technology. As fast internet connection and mass storage become familiar, and companies started switching from hardware to cloud services due to ease of use and reduction of cost. Several companies created cloud services to meet the demand. Similarly, static hard drives are replacing SSDs because of their faster speed and smaller size. In the upcoming days, faster, smaller hard drives with unlimited capacity would be introduced in the computers. Samsung is working on a competing technology called Z-NAND incorporating 3D X-point technology to meet this need. Current research is being conducted on holographic data storage and DNA data storage. Holographic data storage would take the concept of dual laser optical discs to complete a new dimension. Instead of storing data in a 2D pattern, holographic data can store data in 3D dimension pattern using entire thickness of the disk. The single disk has a capacity of 5 TB, which will be available in the upcoming days. The future can be DNA data storage. DNA in our body is a chemical that stores genetic code. DNA can be used as a detailed data storage with each base pair corresponding ones and zeros. A single cubic millimeter of DNA can hold up to 685 tetrabytes of data, which is equivalent to 685 hard drives that you hold at present. The most crucial benefit of DNA storage would be that DNA is stable and can hold data for the millions of years. Talking about the market of data storage, in 2020 there was a revenue collection of 78.1 billion USD from sales of data storage units. Similarly, hosting, storage and computing cloud services had a revenue of 162.8 billion USD in year 2020. Moreover, the information archiving market had a revenue of 6.54 billion USD worldwide. Some of the key players in the data market are Dell, IBM, Microsoft, Amazon.com, Nutanix, HP, Toshiba, Samsung, NetApp, Quantum Corporations. What is the importance of evolution of data storage devices? As there is evolution and development of data storage devices, more data can be stored in smaller devices. Also, there is drastic reduction in the price of these devices that made them affordable for regular consumers. It is also beneficial from an environmental point of view. In 2016 alone, 44.7 million tons of electronic wastes were generated, out of which small tech firms contributed for 3.9 million tons. Only 29% of the total e-waste were recycled. These e-wastes are a severe threat to our environment and human health. Therefore, it is important to start from somewhere. Decrementing the size of storage devices by increasing their capacity would significantly be helpful to decrease the e-waste of technological products, which is helpful to improve our ecosystem.